presentación. Pois nesta primeira intervención da visión de Europa temos con nos a Uwe Kies, que é de Innovawood, unha entidade que ten a súa sede en Bruselas, da que forman parte centros tecnolóxicos e entidades de investigación de diferentes países europeos e que traballan pois para fortalecer ese desenvolvemento competitivo do sector forestal en toda Europa. Así que imos escoitalo xa.
Yes, thank you. My name is Uwe Kies. I'm the Secretary General of Innovawood, which is a European network. I will just present this soon. So thank you very much for the invitation and for having me today as a keynote speaker on the topic of European networks and perspectives of hardwoods in construction. So, of course, we have already heard a lot of innovations also in other fields, but I want to focus a bit more on the construction sector because this is a major driving part now on the European level. Let me see. Where can I move the slides? Okay. Controller has a little delay. Okay. So just to give you an overview, who I'm representing, Innovawood is this European network of research organizations. We have now around 70 members in 28 countries all around Europe, and these are mainly research institutions, universities, cluster organizations, and training centers. And there's also a lot of members in Spain, as you see, and we are also happy that Cera joined last year as a new member. And we are mainly active on European projects, cooperation projects, where we bring in the members and where we also sort of start to advise the European Commission on the advocacy level. So in my talk, I would like to give focus on three aspects. So why do we need more research on innovation in hardwoods? Just a small intro, also from the forest perspective. Then I'd like to give a few really just selected examples of innovative construction with hardwoods. Also, yeah, giving some inspirations maybe how this approach has to evolve, and also give an overview of the European level initiatives in the construction field. So forests in Europe cover 42% of the land and are, let's say, one of the main terrestrial ecosystems we have. And it's actually a very diverse ecosystems. Forests are not the same in the north and in the south and in the east and the west. The JRC reports 78 forest types with over more than 100, let's say, dominant tree species. And mainly 60 important ones are coniferous tree species, so softwoods, and 95 are broadleaf species, which sort of translates into the material of hardwoods. And these forests are, of course, very important for ecosystem functions, so the natural cycles, the habitat, the biodiversity, and as we have heard already in many speeches today, also the socioeconomic role. They are the backbone of the so-called forest-based industries or the forest-based sector, including wood industries, paper industries, furniture, all sorts of uses of timber as a material. And then we can also include non-wood forest products. But this European forest ecosystem, if you think of it as a whole, is really also affected by climate change. And this will have a major impact. And in forestry, we think in long time spans. There will be a shift from the forest tree species matrix. Because of the increase in temperature and precipitation of the climate change, this will favor different types of local climates, and this means the composition of the forest will change in the long run. And this is already a very known graphic from Hanewinkel, showing sort of the shift. If we think in a perspective of forest management up to 100 years, oaks will increase, whereas spruce and pines will decrease. And so the cultivation area actually within Europe will shift more also to broadleaf species, And another very important factor is, of course, also the increase of disturbances as droughts, fires, storms, and pests. This leads also to more risk and uncertainty in forest management, which we have to consider. So as one main, let's say, recommendations from the Resonate project, which is also sort of co-organizing this event today, this means if you have to go more into resilient management, you have to mitigate these impacts of climate change. You have to actually proactively manage the forest and not just leave it alone. You have to adapt and restore forest types, and there is a term pre-storation, so a combination of adaptation and restoration. And the third recommendation is that actually you have to develop these forest and forestry value chains more, so that making value out of wood as part of the objective to improve resilience. But what is sort of the market reality today is that hardwoods really represent only a very small share so far. Only 8% of the total solid wood production in Europe is, let's say, hardwood material. And this goes mainly into the construction sector. 64% are sawnwood and engineered wood products. And another major share goes into wood-based panel products, so furniture. And the reason is, of course, hardwoods and softwoods are not the same raw material from its structure. And another important aspect is that actually the potential to extract value from a tree is much higher in broadwoods, in softwoods than in hardwoods. Basically, you can use 80% of the, let's say, a spruce tree, whereas in an oak tree, it's only 50% of the trunk and the raw material, because the tree has much larger crowns and much more branches, and it's just less potential for value extraction. And that's why this hardwood sector is not, let's say, an economic driving force in the wood sector. If you think now further of developing the hardwoods field, you have to consider that hardwoods and softwoods, there is a, let's say, ecological reason why they are so different. They are very different types of materials, and they have very different mechanical properties. You see on this chart, in the red area, the softwood area is quite confined and quite, let's say, small and uniform, whereas the fields of hardwoods has a much broader range of density and elasticity as some main characteristics. So the challenges for hardwoods research are fourfold, I would call it. Ecological, we have forests that are under climate change, so there's this need for adaptation and to go towards the management of more mixed forests in the future. On the technological side, hardwoods are, as a material, they are much more heterogeneous, and even within one species there is more variation. And these properties and qualities are also very different from softwoods, so we cannot just copy-paste technologies or systems from softwoods to hardwoods. It's actually, we are developing a new field and a new technological area, I would say. It goes also on the basic level of material research. We have to understand hardwoods as a different type of wood materials, and it's not the same as softwoods, definitely. So a big need for innovative products that make the best of these material properties. So it's also not a good idea, I think, to compete directly with the softwood sector, because they are not the same advantages. On the regulatory side, there needs to be a lot of work done. So the European standards at the moment are also mainly focused and based on softwoods, and they are incomplete or completely lacking for hardwoods species and especially engineered wood products. So we need much work on more grading methods, standardization and certification of European hardwoods. And the last, but probably the most important one, as we also just heard, the driving part could be industry or should be industry. There's the need for marketable and scalable products. And again, I'm focusing more on construction here. How can we go into engineered wood products that have a market based on hardwoods? that's the first question. Where are there really opportunities or, let's say, roadmaps where we could go? And then companies have to develop viable business models. So this is sort of the challenge we are all facing, I would say, as a research and innovation community in Europe regarding this hardwoods mapper. So I will just show now that already several companies and people are, of course, working on this. And I will just pick a few selected examples of hardwoods products, which are sort of innovating the wood construction field. So this is, I think, quite already a known product, the Baubuche. It's a hardwood laminated veneer lumber from Pollmeyer in Germany. And it uses, the qualities of beech to create a super strong, let's say, material, a building material, which is similar in a way or can compete with concrete, but it also attains even smaller cross sections than softwoods. Yeah, so it's also outperforming softwood CLT in certain circumstances. Another one is that we actually can combine hardwoods and softwoods. So these are two examples of companies who work on a hybrid cross-section of beams using hardwoods and softwoods together. And this actually optimizes the resource use, so you need, in a way, less material. And you can combine these different strengths of these different species. So this is one, I think, interesting way to go. And as we have heard already also mentioned before, birch is becoming an interesting tree species for the construction sector. Haslacher is already producing cross-laminated timber as a standardized product, and this allows very slender and very volume-saving beams, and also with a very unique look. Yeah, it doesn't look as spruce CLT, and they claim, at least, they also have superior mechanical properties than spruce, because you can much more longer and more slender beams compared to spruce. So again, you are not here. You can compete because there's an advantage of properties compared to softwoods. And then an example from TU Munich, a German research project where we actually not look just at the timber material or the engineered wood material, but you look also in a way of a construction system. How can you make use of this, very difficult properties of beech to create more standardized beam projects who are also useful for larger spans? And so they worked a lot on these very different types of combinations and lengths and combination of different strengths within the components, to create a building system which actually can then be used technologically in the building sector. Another, or let's say this goes more into research and innovation areas where people are now looking also into more complex construction systems where you actually mimic organic structures, because we all know this. The tree is the most optimal structure to use the resource in the biomass way. It grows naturally because it saves energy and material, and to mimic this in construction processes can be very interesting. So this is a project of the University of Kaiserslautern. They actually use spruce CLT, but it will be connected with hardwood laminated veneer lumber to sort of create very strong knots, which mimic in a way, a branch of a tree. And they also have different ways of connecting it with beech in conic dowels. So a very interesting direction to use engineering to copy, let's say, advantages of timber. And then a last one, which is also more, let's say, an inspiring way, quite a disruptive approach. This is from something that is called whole tree architecture. There's a whole area of companies and research centers trying to use this. The idea is not to destroy the timber, the tree, but to use the forces and the shape of the tree as it is, and then use scanners and advanced algorithms and CNC robots to assemble these kind of naturally grown components. And this is an example from, I think, London. Yeah, it's a design office in London. They created a whole barn where the main beam structure in the middle is created out of this different hardwoods logs, yeah, if you want. But this is not just fantasy. There are actually companies also in the US who are creating large barns and large structures with this kind of trees. It's just using the tree as it has grown. Okay, so more ideas just to inspire you where research in this field could go. Yeah, and then I'd like to give a bit of an overview of European initiatives. So, as I said, on the European level, this notion of carbon sinks, cities should become carbon sinks. We are all dealing with the climate crisis globally, and it already impacts us on many, many levels. You just open the news every day. There's a new crisis induced also by climate impacts. But so that's, I think, one reason why timber has become more evident and more visible in the last years, because it can offer, let's say, a part of the solution for climate change mitigation. And the question is, can we really talk of a timber revolution, or is it more of an evolution where step by step the wood sector becomes more important? But definitely there is a strong advantage of the wood sector to contribute to the decarbonization of the built environment. And this only can work if we connect forestry with long life wood products and also with the construction sector, the built environment. So we need, on the one hand, sustainably managed and resilient forests. And we also have to take into account this adaptation to climate change and also ensure biodiversity. So this has to be a holistic approach to forestry. But the timber that can be used from this, let's say, land use can go into long life wood products, and we can innovate and improve a lot there. And also another aspect which I didn't focus yet on, but is that also this long life wood product should become circular. So the idea is that we don't just produce a product which is used and then destroyed again, but that it's actually can be disassembled, that the buildings that we are using these products in, that it can be taken out and be constructed again in a different building. So this circular economy will have a very big impact on the long-term carbon sink function. Yeah, and this can only have an impact if these kind of products are becoming more mainstream, if they can be upscaled, if they can use the material also in a much more resource efficient manner. They have to become circular, and I think the public sector especially has to be a pioneer to incentivize this, that we have a development towards a really strong wood construction sector in the future. And sorry, this was the wrong direction. So this is the narrative which is becoming much more visible in Europe. And one interesting new approach or concept is this new European Bauhaus, which was launched by the President of the European Commission in 2022. And it's the first time that a President of a Commission starts talking about wood, and everybody was really surprised to hear that. We all know that today, building with timber could save up to 40% of carbon emissions in comparison to concrete. By keeping the carbon inside the wood, one day timber could turn our homes and even entire cities into carbon sinks. And this is a very strong message if this comes from the President of the Commission. This is, I would say, one of the best ambassadors for us. And the reason is because she was advised also in the last years a lot from people from the wood sector and from climate research, notably Professor John Schellenhuber, who is the Director Emeritus of the Potsdam Institute. And his slogan is sort of becoming in the last years, reforesting the planet and retimbering the cities. Timber construction can become sort of a true silver bullet to fight climate change. So I'm saying that this should be also our main narrative. If people are listening to us in Europe on we should talk about climate change. We should talk about this possibility that this is a solution to problems actually the whole society is facing. So this New European Bauhaus initiative is actually a project of the Commission. It's sort of a co-creation, a grassroots co-creation movement for the European Green Deal. And I will not go into details, but it has triggered a lot of interest, a lot of new initiatives, prize competitions around Europe, and now also European projects are funded by who are sort of labeled with the New European Bauhaus. And we from Innovawood are part of one alliance that was created because of this New European Bauhaus. We call it the Wood for Bauhaus Alliance, which involves all the major umbrella organizations in the woodworking sector. So the European Panel Federation, the European Confederation of Woodworking Industries, the European Organization of the Sawmill Industry, and also the European Federation of Building and Woodworkers, which represents the trade federations and the trade unions and the woodworking woodworkers. And with this alliance, we are quite active, engaging with this Bauhaus movement. We are following what is going on there. We are writing policy recommendations. And one new outcome is that we have now created a New European Bauhaus Academy Alliance. So this will be a platform for skills and training in wood construction. And the idea is to actually inform other sectors. So the construction sector, the architects, the public planners, the financial sector, to advise them about the benefits of, in this sense, bio-based materials. So it's a bit larger than wood, but wood has a very prominent role in there. Yeah. So how can wood construction can become a solution for also rural development, for urban planning, urban development? This is the focus of this European platform, which will be launched very soon. And then just as my last slide, also as an overview, there are also many policy activities on the national level and on the European level. There is a European platform called WoodPop, Wood Policy Platform. And it actually wants to connect, these different fields and different national initiatives. So what we also heard already in the morning, connecting Europe, connecting the knowledge and the let's say best practices in Europe, and becoming more visible on the European level. And there are a few examples also here mentioned on national programs who are fostering wood building. And if you go inside, actually, some of these initiatives really also foster hardwoods as a main priority. That priority has to let's say, be addressed. If you upscale wood construction, you actually have to develop the hardwood sector. So, And just to summarize this in one slide, how I think we can have an impact altogether. So this is the example of Innovawood, of us as a network, but basically it links to the idea that we have to connect into Europe. We have to, bring in our local, let's say, members and organizations who are embedded in the region and who know the issues and the challenges in the region. We have to connect it to industry and society in one way, and then we can actually develop really meaningful and impactful research and innovation initiatives. And of course, at the same time, we have to link with the European policy level so that this goes together in harmony and, let's say, develops much more synergies to boost the whole sector together. So thank you very much for your attention, and I'm really glad also to answer some questions.
Imos avanzar e continuar, en todo caso deixaríamos a quenda de preguntas para despois da intervención de Klaus Richter, que é catedrático emérito na Universidade Técnica de Munich, en Alemaña, e ademais Klaus forma parte do Consello Asesor Científico de Bioeconomía do Goberno alemán. Cando queiras, Klaus.
Thank you for the nice introduction. Good morning, ladies and gentlemen. It's a pleasure for me to be here today. I was, as a PhD student, a couple of times or of years, even in Spain and in this wonderful peninsula. And I was also visiting this nice place, Lugo, 40 years ago. I have seen many changes. The old buildings still are existing, but I think Lugo has improved significantly, and I hope that also the forest industries will improve in such a way as your town has shown it. And I'm very glad that I could cope and follow what Uwe has already explained. You will see a couple of course, coincidences. We have not talked about the contents of our talks, but you see the keywords Francisco has given me, carbonization or decarbonization and circular economy or cascade use, of course, are part of all the future scenarios we will to talk about in this 3 days, and they are, of course, rather important. So I will try to add on what Uwe has already given, and maybe with a little more focus on science and research activities. Also, maybe in a certain way, a little bit more critical, because we have already also seen in the previous talks that to try to cope what we have learned and what we have established in the last, let's say, 30 or 40 years in the European and worldwide wood industry, the big interest wood has gained, and that now even in the politics, in the European level, wood is a real strong pillar. This is, of course, built on what we have achieved in the last decades, mainly focused on softwood technologies. And now we have to take the big challenge. Can we really try to adapt this stepwise also to what hardwoods are presenting us in the complexity, in the challenges, and of course the property levels and all this stuff has been already shown here. And I will, of course, try to give up a little bit more details. I hope I press now the right where it works. Which widget is this? Okay, I have to have this one. That's okay. This one? This one is okay. Okay. So also the structure, the options for decarbonization very briefly, and then potentials for wood-based materials, based, of course, also on hardwoods. We have made a case study on beech glue lamp, and I will like to conclude the decarbonization with a focus on hardwood forestry and hardwood wood industry, and then the same for the cascading. So cascade use have also been shown by Francesco, and I will also talk about the potentials for wood-based materials with a main focus on hardwoods. That's the structure of my talk. And of course, we all know that, of course, climate change is reality. We have focused the big impacts. The catastrophic development has shown even on our systems, especially in Germany, in couple of years, very dry and catastrophic disasters events in Central European forestry, mainly based on the structure of the forest, but also, of course, impacting then the regional resilience. And of course, the required conditions are we have to ban that the effect or the causes of the big increase in global temperature, which is hardly and surely related to the use of fossil sources. And of course, we have to ban fossil carbon sources by 2050. The next big step is extension and creation of managed carbon sinks. Here, of course, forestry comes into play, in forestry, and of course also carbon farming. This could also be then related to wood industry and the protection of the national carbon sinks. That means forest needs to be also conserved, needs to be also regarded as important carbon sink ecosystems, the wetlands also, and coastal ecosystems. So these are the three main required conditions for decarbonization, and I would say for defossilization, because decarbonization is maybe the main word used. I think it's a little bit misused, because we will also, of course, need carbon from our ecosystems to build future technologies. So to totally ban carbon in our future technologies is maybe not the right way. So I would give a priority to the word of defossilization. Okay, this is too much. So the 6 areas for innovation where decarbonization or defossilization can take place are shown here. I will not go into the details because I will directly jump to the next slide where we can see technology plays a very important role. So technology needs to be focused, needs to be adapted, and the only hope I as a technologist is that on the one hand, technology can try to give possible solutions. On the other hand, we need also us as part of the ones that are using technology. That means the society also needs to be adapted, needs to be informed that we will not be able to continue as we have done it in the last 100, 200 years. So this is clear. We also, our future generation needs to be adapted to what is happening now. This is maybe a fault we have done. We have overused our planets, our resources, and now we have to try to adapt our mechanisms to allow at least a decent life for the future generation. So technology is important. Process developments are closely linked to technology, and of course enablers. This is the human capital, human resources which we are building, and at the end, it needs also to be paid and needs to be realistic also from the economic point of view. And here also, I think this is one of the big hurdles we will also face, that industry, we also, and also our future followers will need to pay also what we are now trying to change. And this is in the beginning also caused with higher expenses. And this is some of the big challenges we also have to discuss. So, Buildings, of course, are causing more than already 40% of the global change effects. This is clearly shown in different studies here from the United Nations Environmental Programme. More than 37% of the carbon dioxide emissions are caused by buildings and constructions. That means with the building material, and wood, of course, is also a building material. It's a main building material. We have something in our hands where we at least try to address those big numbers. And here is also my link to the keyword defossilization, decarbonization. And of course, it was also shown how this can happen. On the other hand, we have to think that building construction, that means the building materials which we are using in order to build the sites, to build the houses and the infrastructure, is less important in the moment because we have improved, and also the other materials in a certain way have improved their technology. It's also the building operation which causes much higher percentages in this 37% of global carbon dioxide effects. So, and here also, I think wood materials, and here also the biotechnology and the technology can play a role, because wood is a material which on the one hand is also strong, and it's also a good isolator. So it means building operation means the losses of energy, how we operate our buildings, cooling and heating comes into play. And here also, compared to concrete, compare maybe also to steel and plastics, wood is an interesting bio-based material which can also play a role in the mitigation and in the reduction of the building operation costs when we are using it with good spirit and with caution. So this picture, of course, I hope all of you know, this is the carbon cycle, the carbon story of our material, wood as a material which is built by photosynthesis of our trees. It takes carbon into the product, and then, of course, as long as we use it, it stops it from being released as it is done in a national cycle into the forest. And of course, the products we are building, especially lumber, especially building materials which are used for a long time in a building and is not prone to decomposition there. This is, I think, the most important argument, which has also, of course, triggered the wood industry development over the last 20 years, because wood long years long years was not realized as a competitive material. But when ecology and when the climate crisis has been coming into play, then people realized, wow, here we have something in our hands which we can use efficiently in order to mitigate those impacts. So it's up to us as partner and active partner in this use and wood chain development story, that we are using timber as long as possible. Of course, we also know there are challenges. Timber is a material which can, of course, burn very easily. So when a wood house and a town built out of wood, it will be, of course, destroyed. Then we have a very soon, not a sink, but a source of carbon, the same in the forest. So everything also is rather critical. We have to really take all the measures to avoid that negative impacts over this development story happened. And here, of course, we cannot talk into the details here, but we can talk in the coffee break. This is what also was shown. This is a little bit the background of the Schellnhuber story, which is the basis of the European Bauhaus. He has said Schellnhuber and his group is arguing in the following way. Long years, you see it, I think there's a pointer here, but it is not shown on this slide, on this screen. Long years, of course, we have used carbon effective materials like steel, like concrete, like plastics and other ones. And of course, we have built up cities and infrastructures which are, of course, based on fossil resources. And now we have the possibility, and this is a plan, this is a model by Schellnhuber, when we are using wood, glulam here, and CLT, but also bamboo as also a bio-based, not a wood, but a grass, but also with good technological properties. And when we see that in the upcoming decades, the human people will increase in number more than ever, we will reach 10 billion people soon. Then we need cities. And here say, when we are using the cities and building the cities out of non-fossil materials like wood and bamboo, then of course we can really change the impact which building materials have and building operations have in the emissions, future emissions of carbon dioxide. This is an hypothesis. And of course, it was also, we have to say this, very much criticized. Where shall the wood come from? Do we have sufficient resources? What is the resource availability we have? And is everything of this story true? So some of the former and additional initiatives also are shown here. So the circular wood product is important. And also I would say we have to go into new and improved wood processing techniques. As we will discuss this today, we will see further very nice initiatives later in this today's presentation of talks. New wood products already have been shown by Uwe, but we also have to go into hybrid technologies. Wood alone will not make it. We also have to combine wood intelligently with other materials, even with concrete, but on a way that very less amount of concrete is used. So this, I think, is one of the important scenarios we will further also discuss. To show it, when we are building those 2 millions or billions of dwellings out of concrete and steel, that means 90% of the future materials will be concrete, and we will go on as in the moment that only 10% of wood impact takes place in the building infrastructure. Then we will emit 71 gigatons of carbon, and we can store only 0.4 gigatons of carbon. When we would be able to change this, that means using 90%, hope I'm too slow. This is 90% of wood and only 10% of concrete. So a very dramatic change in the building processes. Then, of course, the timber, the stored carbon will raise the storing capacity of 75 gigatons, and only 7 gigatons are emitted out of concrete and 28% out of the processes in the wood construction, because wood construction also, of course, needs fossil energies and fossil materials, so we cannot totally reduce the other materials. That's also part of this hybrid technology. But you see, when this would be a realistic story, then of course the global impact would dramatically be affected positively. But it's a hypothesis. So yeah. And of course, when we are looking on what EFI has presented in numbers for Europe, this looks rather good. So when you see the forest area, growing stock, wood the production, and a net annual increment, everything is growing. That means here wood industry seems to be on a very good way. But of course, we also know that climate change affects in the moment our forest ecosystem. So I think the next strategies, the next figures might look a little bit different. In Germany, we have just the fourth or the fifth annual inventory for every decade. We made some, and I guess that in Germany the figures will not look so optimistic as it will be. So where will the future resources come from? And a study from the University of Hamburg has shown that even in Germany, we are using most of our softwoods on a way that the sustainability level is already reached and maybe also surpassed. And only in the hardwood, you see the non-coniferous potential is a little bit given. That means we are relying on hardwood technology, even in Germany. And when you see what happens in Central European countries, this is not a picture from, or let's first talk about the problems we will face when we are using hardwood. So we have seen hardwood are diverse. There's plenty of species are very interesting in specific qualities. But when we are looking on the hardwood properties as industry would like to see them, then we have to say it's really a problematic source of material. It's demanding. For me as a technologist, it's a source of potential innovations. But when you would like to copy what the man-made materials are given to the industry, very narrow property areas, nice to adapt, nice to process, then hardwood properties will be very challenging. So it's really I will not go into the details here. I think you are familiar with these, but I have copied a couple of slides we have discussed with our students, and to say what are the causes why hardwoods are on the one hand very interesting, chemically interesting, but as a building material also rather challenging. Yeah. So high variability, but you see also high strength, high stiffness, bulk density, but of course especially shrinking and swelling, especially with beech. This is a catastrophe, and we have to learn how to cope with this. And durability, very broad arrays. Some of them are very good in durability. We don't need even any preservatives. On the other hand, we have a lot of species that are growing very rapid, like poplar. Even birch needs additional durability measures in order to improve it as a long-lasting material. So here we have really to solve a lot of future questions. But we are able to handle it. So these are all products which are fabricated mainly in pilot plants. Some examples from birch we have seen that are already existing. Pollmeyer is also, of course, here on this slide. This is, I think, the major product which has been produced in Europe on an old technology, but changing from spruce to beech was enormously problematic for the process. And I know that Mr. Pollmeyer suffered long years, and he only could manage to invest in this idea because he earned his money with trading of wood. So this is really a challenge. But from the properties, very nicely, and we can, of course, as already shown, we can try to change glulam or wood building structures in the technical requirements dramatically. We can be very narrow, we can be very slim, we can achieve what the architects are expecting, very nice and slim constructions. This is really potentially available with products on beechwood. And you see the cross sections are really becoming narrow, and we need less material. This is a big advance. But of course, in the fourth chain, we have to go for a lot of solvent solutions for the problems. So especially the compressive and tensile strength perpendicular to the grain is of course considerably higher, and also shear strength is considerably higher, and strength in longitudinal direction also is much higher in hardwoods. And of course, products also what has been formed. So it is nice to go into those processes. And here also a recent publication from the colleagues from Boku in Vienna. They show that is especially, of course, the sawing technology is a very old and not very innovative form of taking rectangular parts out of a round product like a log is. So when we are going into this stranding operations, this could be something where hardwood processing could especially gain value and gain interest. And here I think we are on the beginning of a new technology, hopefully that we are going away from sawing technology, because we are losing 40% of the material in the first processing step. We will use it as fiber and as particle, but for the really target product, it is not the main technology. This is why I think the last example of Uwe was nice, where we have the roundwood. It looks a little bit crazy, but the idea to look to take the roundwood as the main constructive material, which was done in the prehistoric time, when no tools have been available, is really interesting. So we have maybe to learn that it does not look nice. The architects maybe are a little bit frustrated, but that's how it is. But from the resource efficiency, that's a very important step. And resource efficiency is important. You know, we have to couple this. So the application potential, roundwood qualities are, of course, higher. The engineered wood products are, of course, very good. And what are the application potentials in relation to what is the defossilization or the decarbonization? I have shown here technology-wise, I would say, we will continue with the environmental wood products. Maybe the processing can be achieved. Hardwood is, of course, mostly used in interior applications, window, doors, flooring, especially solid wood products. Here, I think there's a future increase possible. Exterior building, decking, because we have always the problem of the durability. I think here we can adapt, but we will not have a steep increase. Wood-based isolation panels. Here I see a lot of potential for hardwoods, and packaging and biorefinery are future markets, certainly, and we will have further future talks here to go into the detail. And the same when we look on decarbonization, I think when we would be able to put more wood in the engineering wood product chain into the buildings, this will will have a certainly high impact and defossilization. The other technologies you see we can continue, but also for the minor qualities, and this is good for hardwoods, wood-based insulation panels, packaging, and also biorefinery. Here I see a lot of potentials that also decarbonization effects can be created by using future hardwood availabilities. So this is my personal view here, and we can discuss on this. The question is also the ecological impact wood production causes is high. And of course, what will be when we are changing also to bioeconomy, when we are changing also the glues we are using in the moment, we are using glues from synthetic production. Step by step, we will be able also to use the tannins and to use the other biomolecules in our products. What is the effect on this? We have made several studies on this for textiles and also for, of course, solid wood, and I will only show you the results for the glulam production. So when we will be really able to go into the glulam beam processing, we have made several scenarios, 1 cubic meter of glulam, but also not only the product, but also the application in a construction, a 5 meter and a 40 meter beam. And you see that on the results here, so the results are improving. That means in future, with future technologies, that means using bio-based adhesives, reducing the strength, adapting the technical standards, the normative values. Then, of course, we can also show that the future possibility to use hardwoods will also have a positive ecological background and ecological effect. So that means there is improvement possible. Yeah. And these are my first conclusions. That means the future scenarios for 2015 predict reduced environmental impacts for hardwood building products, implying an overall improvement and positive option for decarbonization. The greatest reduction is by the rapid growth of the renewable energy share in the electricity mix, coupled with the amendment of scenarios of allow to a smaller crosscuts of hardwood glulam. So the possible options for the more use of renewable energies is also an option for the other technologies, for steel, for concrete in the same way. So here also the other will cope. But this is good for the environment. Doesn't matter if it is from concrete or from wood industry. So in general, we could expect here some positive values. This also affects the third part. That means the substitution potentials, which we are using in the discussion to show up the benefits, they will in future decrease because the others will also gain profit from a decarbonization strategy in the concrete and also in the steel industry. And the last point, the necessary technical adaptation of the process lines as well as the building codes need to be realized in due time in order to allow a hardwood-based decarbonization strategy. That means we don't have to lose too much time. And now the next part is, of course, the cascading. I will not go into the details, but when you are reading all the strategic papers on the bioeconomy, the cascading and the circularity and cascading is a part of circularity, is one of the main pillars of the future bioeconomic strategy, because we will not have sufficient bio-based materials, not only from forestry, but also from agricultural and aqua technologies. There is not more available than the world can produce. And here, of course, we have to, again, reduce it. And therefore, circularity, use one material as often as possible, is the main idea. And of course, this one is shown in a much nicer way by Francisco. So this was the first paper we have realized in 2016 on the principle of cascading in the forest industries. All has been said on this, and the question is, what is the barriers? What are the expectations? And of course, on the one hand of this slide, I have only written some keywords. I will not have time to go into the details. What is important is that we have an increased resource efficiency. So what I've shown you in this diagram, how to process logs to timber, is important. Here we are losing a lot of material, and then of course also the scarcity of the raw materials. We will have plantation forests, and here we can expect a higher production rate, a higher yield compared to natural forests, but this needs to be adapted in the future very soon. The value creation potential is high. With technology, we can do very, very good solutions. All the studies we have done in my institute have shown that especially selected very critical environmental effects are positive when we are going into this cascading industry. Not all, because wood is a bio-based material. I think again also the other materials will get even more profit from cascading. We have a product which starts in the production process with very good and high environmental value, because we don't need energy to produce wood. We only need energy to produce a forest, to manage the forest, and to produce the materials later on. But the pre-effects are very high. And so we have to see how intensive do we invest energy in order to make cascade steps possible. But generally, we have to go into this way. And then, of course, we have also this very long extension of the carbon storage time. This is important, an important argument for cascading. But there are, of course, many questions of quality, technical implementation. We have to face contamination because the old products have been used. We have to find new ways in order to operate wood products. The customer needs to be accepting this. The legal restrictions are very, very high. This also needs to be solved in due time in order to make use of cascading. And there's also an overall lack of assessment. That means we have to use research in order to cope with the questions in the future anymore. But no time to go into the real details. It is possible, of course. You see here what we have realized in different EU projects. But we have also seen that the yield from the incoming waste materials or used material to the final product, which we can go into the next cascade step, is of course reduced. We have started with 20% yield, which is rather low, because to clean it, to make all the nails and the screws effects, get rid of those, it's really demanding, but generally it is possible. Yeah, but we need also glue. We need also to put them together. That is also a step to reduce the volume of the products. But generally, the idea is rather good. I think in the new fields of particle and fiberboards, and also and you know that there are research projects running. The EU fiber goes into this direction, and also in the biorefinery, there's of course a lot of potential, because then the quality of the input material, at least the volume, is not of primary importance. Here we go into the mess, and that hopefully the nice biochemicals are still conserved over the lifetime. This needs to be solved, but here I think there's a lot of potential also for ongoing research. And then this is an ongoing project we have done. So we have a running project in the moment to see when we are using 2x4 framing elements, and this is what we have done. We have taken an existing 2x4 framing element a German wood house producer is producing, and we have then gone into the process of taking all the elements out. And here, of course, we are coming to a huge variety of different materials. You see a little bit of boards, you see a huge amount of insulation materials, you see some massive woods, but you see also a lot of materials which have been used to put the things together, nails, screws, and other connective materials, and of course also a lot of waste. That means our constructions in the moment are not done for recycling. That means we have to also consider adaptations in the building process. In order to make this possible and to show such an easy picture, shows the people we have to adapt the processes. Shall we need different ways of connecting, that we can dissolve the problems, the products easier? Because when everything is glued, it's very difficult. When it is screwed, it's a little bit better, but there are options for improving even existing technologies for the future use in a cascading chain. This is important, yeah. And you see also this disassembly and reuse options. We can also make some nice investigations on this. And when you see here the results of our study, this is a global warming potential of disassembly and reuse of existing constructions. And you see here, when we are going into this design for disassembly and recycling, then the carbon dioxide will be reduced. That means we can use also those technologies in order to decarbonize or to make an effort in defossilization. So this is really also proved now by some scientific-based models. And this also has been shown by Uwe. Hardwoods, of course, are at least much better to be used for improving disassembly, because they have better qualities. I've shown them. And here, those connectors can be certainly used in 20 years. We can take the elements out and do not have to destroy all the materials. So here, hardwood have really positive and future properties, which I think are interesting, and we have to go for this way. So, and then I will close with this last 3 points. Today's recover and recycling rate in the wood building industry is rather poor. So we are calculating about 10%. On the other hand, we know that we are using 100% of incoming material, but our industry produces 200% of materials, because we are also using a couple of, I'm closing. We are using a couple of materials, even in our existing cycles, plenty of time. So we are rather good in the cascading issue in the moment, because all our materials which are produced in the sawmill process are used as fiber materials, or at the end, at least as energy material. Yeah, this is, I think we have a good recovery rate, but the recycling rate is low compared to steel, compared to other competing materials. In the current ongoing case studies, we have done positive values for wood in circularity are shown, and all future strategies on wood with potentials in the bioeconomy are relying on the circularity effects in order to match the demand for future-based materials with the planetary boundaries. Because this is clear, the planetary boundaries are given. Biodiversity will have a much higher importance in future forest management. That means we cannot take all the wood out or go on as we have done. So European revolution going to the direction when 30% of the ecosystems are not used to be used anymore, then we have less material available. And we here in Germany and even in Spain have a good forest resource availability. In other parts of our world, this is not the case. So we have to go into the circularity. And then so far, no specific studies are available where hardwood really is used in reuse, because hardwood is used not in the same way as softwood in the past. So we need to go also in studies where hardwood properties and hardwood positive values can be shown up also in this studies on recycling or on circularity. And especially I think, and here also only some pilot studies are available, the potential for hardwoods in the biorefinery is high. And here, of course, you also can be look in the future with rather positive esteem, because here hardwoods are certainly more interesting for the industry as softwoods are. So with this, I would like to thank you for your attention. And I know that I have maybe talked a couple of minutes too much, but that's how it is. Thank you.